Hello, this is Madhusudan KR. USN is 1PI14SCS12 doing a seminar on stop and wait and sliding window protocol for the fulfillment of second semester MTech Computer Science in a subject Advanced Computer Networks. Before directly going to what the protocols are, let's go for the basic definitions in the networks. So basic transmission: sender gets a request to send a frame to a receiver. So frame are sent by a sender to the receiver and frames gets arrived in the receiver. The vertical line that showed here is a time. A request has come to the sender and the sender sends a frame to a receiver and a frame is received and arrived in the receiver. In order to measure the performance of a frame transmitted from sender to a receiver or receiver to a sender, we have four metrics. They are transmission time delay, propagation time delay, processing time delay, queuing time delay. Transmission time delay indicates time taken to emit all bits into medium. That means time taken to transmit all the bits of a frame to a network. It is known as transmission time. Propagation time is time for a bit to traverse the link. It means time for all the bits of a frame to transmit from a sender to a receiver. Processing time delay is time spent at the recipient or intermediate node for a processing. And the queuing time delay is waiting time at the queue to be sent. Okay, so let's just read from the diagram. This model shows how a frame is transmitted in a error-free transmission and in a transmission where there is an error. Let's just consider it being the source and the destination. As we study the performance metric like transmission time and propagation time, transmission time indicates that complete frame sending to a network. So this indicates a transmission time, and propagation time is from a source to a destination. Delay in sending a frame from a source to a destination. This could be termed as propagation time delay. So and this vertical line indicates the time. Here we can see some errors. Frame 2 has not yet reached destination, and frame 3 as well. Like it has it's not the frame 4, but a garbage frame has entered to a destination. Okay, so let's see why we actually needed this stop and wait protocol and sliding window protocol. So in a reliable transmission, reliability is a function that may be provided at the link level, that is like physical link level, but in many modern link technologies omit this function. Reliable delivery is frequently provided at higher levels, including both transport and sometimes like in application layer. So this is usually accomplished using a combination of two fundamental mechanisms. They are acknowledgement and the timeouts. Okay, so the recipient of acknowledgement indicates to a sender of a original frame that its frame was successfully delivered. If the sender does not receive an acknowledgement after a reasonable amount of time, then it retransmits the original frame. This action of waiting a reasonable amount of time is called a timeout. So this gives a clear distinction between timeout and acknowledgement. So this action of waiting a reasonable amount of time is called a timeout. The general strategy of using this acknowledgement and a timeout to implement reliable delivery is sometimes called as automatic repeat request. So this section describes about two automatic request algorithm. They are sliding window protocol and a stop and wait protocol. Let's go for the stop and wait protocol. In stop and wait protocol, first of all, it's a simple automatic request scheme. So the main idea behind this is source transmits a frame, destination receives frame and replies with an acknowledgement, and source wait for acknowledgement before sending the next frame. Destination can stop flow by not sending acknowledgement. Works well for large frame but inefficient for a small frame. This I'm going to show you the example as well. For example, let's see in a diagram. So sender sends with a frame 0 and receiver sends an acknowledgement. Again sender sends a frame 1 and receiver gets a acknowledgement 1, frame 0 and acknowledgement 0. This is shown in the figure, and acknowledgement number is given 0 and 1. So next, these are the scenarios with which for the stop and wait algorithm. First scenario is being acknowledgement is received before the timeout. Okay, still sender will this is a best scenario with which sender receives an acknowledgement for the frame sent by a sender, and the sender in the next case the original frame is lost. That means a frame that has been sent from sender to receiver has been lost. Again, hence sender sends a frame after some amount of time. So time out is actually being 2 times RTT. RTT indicates round trip time. So in the second scenario, frame has been sent, but the acknowledgement that is sent from a receiver has not reached to the sender. Hence sender sends this frame again to the receiver. Okay, this is third scenario in the stop and wait protocol. And the timeout in the next is the timeout of an acknowledgement. Okay, so this scenario describes how sender to receiver fails. First of all, so sender sends a frame and receiver gives the acknowledgement to a frame, but acknowledgement has been sent after a timeout. Hence sender retransmits the frame, again it transmits the acknowledgement. These are the scenarios in stop and wait protocol. Okay, I just said that it has a disadvantage for the smaller frames. That's what it's been described here. Consider, for example, a 1.5 megabits per second link with a 45 millisecond round trip time. This link has a delay into bandwidth. This gives a amount of bits that can be transmitted at a time in a link. This product is being 65 kilobit or 8 kilobyte, wherein which so possibly only 1 kilobyte has been sent, maximum sender rate. So this indicates that 1/8 of the link's capacity is only being used. Okay, so remaining 7/8 is not being used at a time. Hence this gives a disadvantage over stop and wait protocol. Hence we go for sliding window protocol. In a sliding window protocol, the problem of stop and wait is not able to send multiple packets, and we are not going to use the link completely. Hence we go for sliding window protocol. Sliding window protocol allows multiple frames to be transmitted. Receiver has a buffer of W called Windows size frames. Transmitter can send up to W frames without acknowledgement, without ACK. Each frame is numbered, sequence number, and bounded by size of a sequence number field. Thus frames are numbered modulo from 2 power k to 0 to 2 power k minus 1. Acknowledgement includes number of next frame expected. This could be showed in this diagram as like this. There are 3 frames with which sender is sending to a receiver, and gives a acknowledgement to each frame. This is what and the time vertical line shows the timeline for the sliding window algorithm. Basically we have a windows in a sender as well as the receiver. Data structures that are used in sliding window protocol are as this. So the sender also maintains the following invariant. So like this. First of all, in a sliding window, lost frame sent and lost acknowledgement received. Lost acknowledgement received and lost frame sent minus this gives the sliding window size. And in a receiver side, LAF minus LFR lost LFR. So this gives the receiver window size. Using this data structure, it is possible by the sliding window to flow the control. Okay, so let's just see in a flow where frame that has already been transmitted here, that means 0 to 7 frames has been transmitted, where these are the frame sequence, 0 1 2 3 4 5 6 are the frame sequence, and 0 to 7 frames has already been sent, but last acknowledgement that have received from the receiver is the 5th acknowledgement, and the last frame transmitted is this. So the size that those are, we can transmit are 0 1 2 3 frames, windows of frame that may be transmitted, because we haven't got 6 and 7 basically. So that shows in a sender perspective view. Okay, 7 is the last frame that has been received from the sender. This receiver has acknowledged the frame of 5th, so the window size remains to be 0 1 2 3 4 windows of the frame that may be accepted. Window expands from leading edge as acknowledgement are sent. This is from the receiver perspective, and that's it for today. This is for sliding window and stop and wait protocol. Thank you.